Let us have one example on conditional probability density function. Suppose that two random variables are jointly normal and we want to find a conditional distribution of one of them given the other one. So if they have a jointly normal distribution, so using this equation, we could find a conditional distribution of y given x, and similarly you can find a distribution, conditional distribution of x given y. So in this case, we will have to write the expression of for the numerator and denominator, and then try to find the conditional PDF of one of them given that we know the other one. So we know that if there are zero mean and if they are jointly Gaussian, so this is the joint distribution. PDF, which is divided by the marginal PDF. Okay. Now, what we see here is that we have a constant. Here we have a constant. Then we have e to the power of something and e to the power of something. So we could divide the two constants, simplify it, and e to the power of something divided by e to the power of something is going to be e to the power of the subtraction of the two. So if you subtract these polynomial of second order minus this polynomial of second order and then do some manipulation, you get these results. And also if you divide these two guys, okay, this square root of 2 pi will simplify with 2 pi, gives you this one. This sigma 2x and this sigma 2x here will be eliminated, and then this will remain here. And then the subtraction of the two polynomial, these two guys, will give you this one. So what we see here is that in this expression, we see that this distribution of y given x is a constant multiplied by e to the power of a polynomial of, so this term here is a polynomial of second order in terms of y. Or in other words, the distribution is e to the power of a second order polynomial, which means that this is a normal distribution. So what is the mean of this normal distribution and what is the variance of that? So basically, we could see that given the knowledge that x takes this value, the random variable y has a normal distribution. Moreover, so this guy is the variance. So the variance of random variable y given x equal x is equal to sigma 2y times 1 minus rho to the power of 2xy, so the correlation coefficient. So obviously this guy is less than 1, so this guy is less than 1, so we see that the variance is smaller than or equal to sigma 2y. So the variance is exactly equal to sigma 2y when rho is equal to 0, when they are independent. So when they are independent, the variance is not reduced, but if they have some correlation, proportional to the correlation 1 minus rho 2, the variance is reducing. So if rho 2 is exactly equal to 1, it means that they are completely degenerate, so the variance of y becomes 0. So given the knowledge of y, you will be able to reduce variance of y to 0. So that means that in that case, y is a scalar multiplication of x if rho is equal to 0. Moreover, in this case, the mean of y given x equal x will become, this is going to be your mean here, the expression of the mean, which is equal to rho. sigma y, rho xy, sigma y divided by sigma x times x. So which is a constant number multiplied by x. So this is the expected value of y. Expected value of y when in the absence of any knowledge about x was 0, because we said that they have zero mean. But if you have knowledge of x, then y becomes a normal random variable with a reduced variance. With a reduced variance here, this is the reduced variance, and this is the amount of the reduction. But the mean becomes non-zero. So the value of x, this is the best mean square error estimate of y, provided that you know x. This is also the best nonlinear estimator of y given x. So in the case of normal distribution, a nonlinear estimator, optimal nonlinear estimator, and linear estimator, they are equal. So given the condition, the knowledge of x, the expected value of y given x is equal to this guy, and is different with the case that where we don't know the value of x. Moreover, the information x equal x results in reduction of the variance, and these coefficients 1 minus rho 2 determines the variance. And obviously, this example shows that if you have some knowledge about one of the random variables, the uncertainty, the variance of the other one is reducing.